On April 13, 2026, a Chinese automaker known as Geely gathered the media for a major event and revealed an achievement that experts had long labeled as physically impossible, not challenging or costly, flat out impossible. The figure they displayed was 48.41%. And if that just seems like another random percentage, allow me to break down exactly what it represents in everyday terms. Whenever your vehicle consumes gasoline, the vast majority of that energy simply vanishes. It escapes through the tailpipe as wasted heat, gets absorbed by the engine components, or dissipates through friction in moving parts. A typical vehicle from leading manufacturers like Toyota or Volkswagen converts only around 30% of the fuel's energy into actual motion. The remaining 70% is lost forever, mostly as useless warmth that provides no benefit. For more than a century, specialists have worked tirelessly to reduce that loss, yet the highest thermal efficiency ever reached by any production car engine stood at just 41%. Toyota treated that milestone as a historic triumph. They invested enormous sums to reach it and publicly suggested it represented the practical upper limit. Any further gains, they implied, would demand unreasonable expenses and bump up against fundamental physical boundaries. Geely stepped right beyond that barrier as if it barely existed, verified through rigorous testing, independently confirmed, and officially entered as a Guinness World Record. This represents far more than incremental progress or a minor tweak. It marks a complete shift in what's possible for automotive powertrains. The most fascinating aspect isn't even the percentage alone. It's the innovative methods they employed to get there. The tail features a swirling vortex within the combustion chamber, a power unit designed to operate at contrasting temperatures simultaneously, and an integrated 11-in-1 assembly that bears little resemblance to conventional setups. If this is your first time watching and you enjoy deep dives into innovations that reshape our future, tap subscribe and enable notifications immediately. We spotlight these pivotal engineering advances as they unfold, and you won't want to overlook what's ahead. But before we continue, let's truly grasp the significance of this breakthrough. To appreciate why 48% feels groundbreaking, you first have to see why 41% was once viewed as the absolute peak, and why even 40% felt unbreakable. Picture a gasoline engine as a controlled blaze contained within sturdy metal casing. Fuel enters, ignites, the resulting pressure drives a piston downward, and that linear force eventually rotates the wheels. Straightforward in theory. The issue arises because combustion generates intense thermal energy. That heat doesn't selectively head toward propulsion, it disperses indiscriminately into cylinder walls, surrounding air, and exiting gases. The system battles non-stop to channel energy productively, yet it loses the majority of every cycle. Physics includes a concept known as the Carnot limit. No need to remember the term, but it boils down to this. Heat engines face an unbreakable mathematical boundary on maximum efficiency. It hinges on the temperature difference between the hottest combustion point and the coolest exhaust. A wider spread allows more usable work in principle. However, practical constraints apply at both extremes. Excessive heat risks melting components, while overly chilled exhaust impairs emissions systems. For generations, teams at Toyota, Honda, BMW, and Volkswagen viewed 40% as an impenetrable barrier. Advancing from 35 to 41% required massive funding and years of meticulous development. Toyota achieved their mark through an ingenious approach called the Atkinson cycle, slightly extending intake valve timing. This adjustment cut unnecessary compression losses and added modest efficiency gains. When their 2.5-liter dynamic force engine reached 41%, the sector celebrated widely. Technical articles declared meaningful further improvements unfeasible without prohibitive costs. Many concluded battery electric vehicles represented the inevitable path forward, questioning the value of refining an aging technology supposedly on its way out. That perspective proved to be a costly strategic error in today's car industry. As traditional Western brands committed heavily to all-electric lineups, innovators in China pursued an alternative path, redesigning everything with fresh eyes. This mindset created the initial breakthrough. It originated from a familiar name that delivered an early alert many overlooked. Before diving into the 48% milestone, we should examine the 46% mark, as that's truly where momentum accelerated dramatically. BYD, short for Build Your Dreams, examined conventional hybrid architectures and deemed them fundamentally outdated. In typical hybrids, the gasoline engine and electric drive work together directly on the wheels. The engine constantly adjusts RPM, accelerating uphill, idling at stops, cycling through gears via complex transmissions. These frequent speed variations pull it away from optimal efficiency zones. BYD proposed a smarter strategy. What if the engine rarely powered the wheels directly? Instead, it operated steadily at one ideal RPM solely as a generator producing electricity. Electric motors would handle all propulsion, allowing the combustion unit to focus exclusively on its most efficient operating condition. Free from road demands, engineers optimized it precisely for that single point with zero compromises. This yielded their iHEV technology, achieving 46.06% thermal efficiency in the latest generation. Automotive journalists worldwide reacted with surprise. A 5-point efficiency leap appears minor until you recall Toyota needed roughly 2 decades and billions to climb a similar distance from 36 to 41%. BYD accomplished it far quicker through a radically fresh concept. Established manufacturers experienced a brief internal alarm. Most then reverted to existing plans, dismissing it as a localized phenomenon unlikely to appeal broadly in Western markets. They offered similar skepticism toward Japanese brands during the 1980s. We remember the outcome. Yet while everyone digested Bide's accomplishment, Geely had already invested 2 years developing the next leap that would overshadow even that advance. The foundation lies deep within the combustion chamber, in an area previously ignored. The vortex within the cylinder. This section becomes truly remarkable. Geely's latest intelligent hybrid setup didn't merely refine prior designs, it discarded conventional assumptions about air-fuel blending. This single innovation accounts for a major portion of their record efficiency. Standard engines suffer from inconsistent mixing when air and fuel enter the chamber. Imagine adding cream to coffee without stirring. Streaks and layers form. Rich zones sit alongside lean areas. Ignition then triggers uneven burning that propagates gradually like a slow front. Heat from initial combustion dissipates into metal surfaces before full ignition completes, robbing significant energy. Geely's team addressed this via their innovative vortex combustion technology, essentially creating a fire tornado. They re-engineered intake, port geometry, and angles. Upon valve opening, air rushes in with forceful rotation, generating a rapid, organized swirl, a true vortex inside the chamber. When sparked, the flame front expands uniformly in every direction at once, thanks to thorough premixing from the turbulence. Burning becomes rapid, complete, and focused. Nearly all energy propels the piston downward with minimal loss to walls, cutting emissions and boosting output. Pushing combustion intensity this far introduces risks, however. Higher pressures and temperatures heighten chances of detonation, uncontrolled ignition, causing destructive shockwaves that damage components quickly. Overcoming knock had long capped progress below 41%. Geely's solution proved equally innovative. The power plant operating at opposing temperatures. Textbooks warn that extreme compression combined with intense heat invites engine destruction. Pushing boundaries this aggressively seemed destined to fail internally. That limitation explained decades without progress. Geely's breakthrough involved intentionally creating hot and cool regions within the same unit. Conventional cooling circulates fluid uniformly, a compromise treating all areas identically despite differing needs. Geely divided the system into separate circuits. The cylinder head, site of peak combustion, receives aggressive cooling to maintain low temperatures. This preserves dense intake charge until spark, enabling safely higher compression ratios that extract more work per cycle. Conversely, the lower block housing piston movement stays warmer on purpose. Elevated temperatures reduce oil viscosity, allowing pistons to glide with far less resistance. Reduced friction translates directly to more energy reaching the drivetrain rather than generating extra heat. Thus, one engine achieves high compression up top while minimizing drag below, goals that traditionally clashed. Geely's dual-zone setup reconciles them via smart electronic pumps that monitor conditions constantly and modulate flow in real time. It defies old assumptions, which is precisely why it succeeds where others hesitated. Yet superior combustion efficiency covers only part of the equation. Delivering that power to the wheels without transmission losses completes the picture. Geely's solution here matches the rest in boldness. Eliminating traditional transmissions. Even a highly efficient engine loses value if power dissipates through bulky, lossy gearboxes. Conventional automatics, despite their sophistication, add substantial mass and drag with numerous components, clutches, converters, and linkages. These sap energy before it reaches the road, often exceeding 100 kilograms while wasting noticeable percentages. Toyota's hybrid planetary system was innovative decades ago, but now feels dated for modern applications. Geely began with a clean slate, creating their 11-in-1 intelligent hybrid drive module. This integrated unit combines the engine, generator, dual electric motors, power electronics, and cooling elements into one lightweight package. Overall powertrain mass decreased by about 13.5% versus legacy hybrids. Absent are traditional shift mechanisms or fluid circuits. During roughly 90% of typical trips, the engine stays mechanically decoupled from the wheels. It runs optimally to generate power, which flows to the battery or motors for instant, silent response, mimicking pure electric driving. Only during sustained high-speed cruising does the system engage a direct mechanical link for better efficiency, bypassing electrical steps. Sophisticated control logic evaluates optimal routing dozens of times per second, factoring in route data, upcoming terrain, and energy needs to maximize economy dynamically. The outcome: verified real-world consumption of 22 liters per 100 kilometers, a production vehicle record, with potential ranges exceeding 2,000 kilometers per tank. These stats fundamentally redefine vehicle capabilities. What this development signifies globally. Let's be straightforward. Battery electric cars excel under ideal scenarios, quiet operation, strong efficiency, and no direct exhaust. Yet they involve practical compromises many drivers worldwide still hesitate to embrace. Larger electric SUVs often carry battery packs exceeding 500 kilograms. Public charging remains limited in vast regions, and concerns about distance create genuine hurdles for everyday use. Geely's intelligent hybrid approach offers an alternative transition strategy. Daily drives deliver the refined, responsive feel of full electrics, paired with unrestricted long-distance capability via conventional refueling anywhere. Operating costs align closely with electrics in many areas. Importantly, this performance comes in a capable full-size SUV, not just a compact model. For established Western and Japanese manufacturers, it poses a serious test. Europe birthed the combustion engine, dominating for generations, while Japan perfected it over decades. Now the efficiency crown sits with a relatively new global player. Bridging such a divide demands more than quick fixes or marketing. It calls for renewed R&D focus amid simultaneous pressure to electrify fully. For buyers everywhere, this rivalry brings positive momentum. Past examples show that bold technical competition drives down costs and raises standards industry-wide. Incumbent brands will adapt eventually. The real uncertainty lies in how much shifts before then. Above all, Geely has demonstrated that internal combustion retains substantial untapped potential. Barriers stemmed less from physics than from assumptions about feasibility. If you've stayed with me until now, you possess deeper insight into engine efficiency than many professional commentators. And that seems like the perfect note to conclude on. If this breakdown resonated with you, please like, subscribe, and turn on notifications to catch future analyses. We'll track how traditional players react, which promises to be compelling viewing. I'd love your perspective in the comments. Does this advanced hybrid represent the ideal stepping stone toward widespread electrification, or will pure battery vehicles surpass it sooner than predicted? Share your thoughts below. I review them all. Catch you in the next video.